First up, the disclaimer. Nothing in this video is intended as financial advice. Please pause the video now and read the disclaimer in full. For complete transparency, I'm going to point out I have not been paid anything for this video and I do not hold any tokens or equity. Anytime I do is always fully disclosed. I'm not going to include a long introduction here because quite honestly, Piers does a far better job of describing Radix than I ever could. Instead, I'm just going to introduce what you guys are going to be seeing throughout this video. We start off pretty technical. We talk about what Radix is and how they're solving that scalability trilemma through the use of sharding. Now, if you're thinking that sounds too technical and maybe that doesn't interest you, the good thing is there are time jumps in the description to all of the topics that we discuss. So if you'd like to jump ahead at any point to the specific things that you want to hear about, feel free to do so. After the technical stuff, we move on to more of the business applications, discussing how Radix fits into the security token space and how they're improving on the current system out there. With that all said, let's begin with the interview. So I'm here today with Piers Ridyard, the CEO of Radix. Piers, thank you for joining me.
Thank you for having me, Tom.
Perfect. So let's jump in with our first question. The scalability trilemma.
Yes.
This is scalability, security, and decentralization. And essentially, the theory is that you can't solve all three at the same time. So
Not with the blockchain, no.
So this is, yeah, that's what I was going to say. You concluded that blockchain and DAG architectures are not good for solving that.
Right.
So you ended up architecting a DLT structure. Do you want to first explain, number one, what a DLT structure is?
Yeah.
And number two, how this architecture allowed you to increase scalability without sacrificing security and decentralization?
Sure. So DLT, for those who don't know, the industry term is just means decentralized ledger technology or distributed ledger technology. It's just a broad, very generic computer science term for blockchain or directed acyclic graph.
With blockchain being one type.
With blockchain being a type of DLT and
Yes.
DAG being another type of DLT, and what we've created, Tempo, being another type of DLT.
Okay.
But the way that we approached it was sort of slightly different. Instead of going, well, instead of first saying, well, how can you create a Byzantine fault tolerant system? How can you create a consensus that brings out truth? You first go, well, let's look at the data problem. And the reason I say there's a data problem is because if you're wanting this to be like the internet, as universally usable as the internet is, a public commons that everyone can build things on top of, then you have this problem that the internet doesn't, right? So on the internet, I send a packet of data, and that's a TCP/IP packet, and the two servers that sent and received it remember that, but the internet doesn't remember that packet of data. The problem is on a DLT, if you want to do transactions, it has to remember what the transactions were. Or if you want to do smart contracts, it has to remember what the states of the smart contract were. So if I send a transaction to you, then you send that same tokens that I sent to you to someone else. The network, for it to be trustless, has to remember the order of those transactions and that they occurred. You suddenly have this data issue of how large is the database going to be? How large is the blockchain going to be? Like Ethereum, 139 gigabytes and growing. But actually, 7 billion people, 24 billion devices, doing some transactions every day, that really adds up very quickly. And if it's got to be immutable, has to remember, then you can't throw anything away, really. Sure, you can do some transaction pruning, maybe, but generally speaking, it just gets bigger and bigger and bigger. So we started with that data problem. You need a database big enough for 7 billion people and 24 billion devices to use it simultaneously without throughput issues or bottlenecks. How do you do that? And the answer is you don't dynamically shard. And sharding is cutting up things, right?
Yes.
So we talk about sharding blockchains or sharding DAGs or sharding databases a lot. And the way that it currently works with smaller data problems is you go, oh, there's too much data in this database, so let's cut it into two. And then there's too much data in these two databases, so let's cut it into four. There's too much data in these four databases, so you just cut it as it gets bigger. Problem with that is you've got to tell everyone where that new data is. You've got to be like, oh, now these nodes are servicing this part of it, and these nodes are servicing this part of it. And then you cut it up again, and you're like, oh, these nodes are now doing these bits of it. When Radix, we went, that's just not going to work at scale.
Yeah.
You get way too much overhead, and it becomes too difficult to dynamically shard and actually keep everyone up to date.
And
so
presumably cross-shard communication becomes a major issue.
cross-shard communication becomes a major issue, because how do you know where you need to route the transaction to? Right, exactly. So we went, okay, let's just make a set shard space so large that you're never ever going to have to cut it up again.
Okay.
So let's start with 18.4 quintillion shards, which is 2 to the power 64. It's a big number. And so we looked at that and we went, how do we know that's big enough? And we said, okay, well, Google warehouses around 10 exabytes of data. That's all of YouTube, that's all of Google services, that's all of Gmail, that's all of G Suite, that's all of their copy of the internet. They have a copy of the internet, and every time they push an update to Android or to Chrome, they test it on their copy of the internet to make sure it doesn't crash anything before they roll it out into the real, which is pretty cool.
I did not know that.
Yeah, so 10 exabytes of data divided by our shard space gives you 4 bits per shard. So tiny, tiny, tiny amount of data per shard, even though you're storing an immense amount of data. So that gets rid of the, you have to keep chopping up the database problem. But also what it does now is it gives you permanent addresses, because you can say if it's set shard space, you're never going to have to change it. If something lives on that shard, it's always going to live on that shard. So if you want to retrieve that information, you always know what shard you need to go to. And on Radix, the way we do that is we take your wallet address. Your wallet address is a 256-bit number. We modulate that down, simple mathematical operation which concatenates, makes it smaller, makes smaller the address, and says, you live on shard 30, and I live on shard 50. So if I want to spend from my wallet, I have to spend from shard 50. And if you want to spend from your wallet, you have to spend from shard 30. You can spend to 18.4 quintillion shards, but you can only spend from the shard that your wallet, exactly. And that also means, unlike blockchain or unlike DAGs, if you want to retrieve information, like what's my historical transactions? In a blockchain, you have to go back through all the blocks, and you go, this block, is there any of my transactional history here? Yes, no. This block, is there any? Yes, no. Blah, blah,
Whereas
blah,
you
blah.
can just look at your individual shard and see what's come and
You
gone.
just go, return to me all of the data on that shard, but because it's been cut up so small, it's only a small amount of data. Right? It'll be my transactional history and maybe 1 or 2 other people, even if there's 7 billion people using it, because 18.4 quintillion is such a huge number. So that allows us to have massive data scalability. We then use that as a way of making the consensus and the system really efficient. Because what we're doing now is we're grouping together related transactions, we're ungrouping unrelated transactions. So if I'm spending from shard 50 and you're spending from shard 30, then there's no need for there to be consensus of any transaction that I send versus any transaction you send against each other, because they don't need to be ordered against each other. I don't need to have consensus vis-a-vis each other. We just need to have...
You only need it on one individual shard.
I only have to have it on one individual shard. Was that a valid transaction on this shard? Yes, no. Not, was this a valid transaction across this entire ledger? So that means that you get massive throughput, because if you don't have to care about the consensus of transactions vis-a-vis each other on every single shard, then your throughput is basically the maximum theoretical throughput of a shard, which we think is about up to 80,000 transactions per second on Radix, and then multiplied by the total shard space of the network, which is 18.4 quintillion, which we think is sufficient. 18.4 quintillion times 80,000 transactions per second seems sufficient even for everyone to be using it simultaneously.
So you guys actually have a testnet up and running?
Yes, which is unsharded.
Okay.
It's an unsharded testnet work right now.
Okay. I was going to say we'll come back to that, but that sounds interesting. Let's go with that. Why is it not currently sharded then?
So when you're building any aspect of this, what you want to do is you want to validate each stage. And the first stage that we're validating is consensus. Does consensus work within a transactional environment? Now, if you introduce the sharded environment, you get a lot less overlapping, conflicting ordering information that you have to solve than you do if you have it all on one shard, because all transactions are going between the same wallets on the same shard. So there's a lot more overhead for all of the nodes to work out what the ordering is and etc. Because it doesn't get to use the efficiency of the data structure that we've created.
Okay.
So we're basically forcing it into a horrible data structure to make sure the consensus works.
Okay.
And then the next level is then to go, okay, well now we've done that testing bit, let's then shard it and see how much more we can push it. And so we're just about to reach that next stage where we're now rolling out node runners, which is the next step, which now allows people to download their own nodes and try in this unsharded environment to see if the transactions work at throughputs of 2,000-3,000 transactions per second, which is what we're pushing through the testnet at the moment. And then later on, to then start sharding it and then see what kind of numbers we can push from there, which are going to be a lot higher, but actually from a technical point of view, is slightly less challenging actually in the Radix environment than the current environment, unsharded environment is, because you get a lot less conflicts because that are occurring just because of the horrible data structure you get as a single sharded environment, which is the problem with blockchain in the first place.
Okay. That makes a lot of sense. Now, I love the approach you guys have taken. I was watching a video of you actually talking on stage earlier today, and it was from May 2017. And bearing in mind the amount of money that was being raised by ICOs at that point, and particularly the 6 months after, you could have easily taken that approach. You could have gone down the money grab, let's get as much money while money is very, very cheap and easy. Yeah. But you didn't.
Yeah.
And I have a lot of respect for that.
Thank you.
One thing what would you say to potential criticism that after 6 years you have a testnet without sharding? Do you know what I'm getting at there?
Yeah, sure. We basically started from scratch, right? We've gone, what doesn't work with blockchain and what doesn't work with DAGs? And it's not just the data architecture, it's also the consensus. So we had to go from Byzantine fault-tolerant consensus mechanisms like proof of work and proof of stake and voting by other means, and completely rethink that and start again from scratch. So the first thing that we had to get right was make sure that we could get a fault detecting algorithm to work at a 99% malicious node rate, and n minus, well, it's actually n minus 2, but yeah, 98%. And so the technology validation has been very much around consensus that works within the data architecture that we've created, but we want to validate the consensus first. So that's what we've been doing up to now. But it's been designed for sharding. So the next step of actually introducing sharding, although that sounds the harder bit, because everyone's like, how do we shard a blockchain? How do we shard proof of work? How do we shard proof of stake? We actually started with an algorithm that's designed specifically for sharding. Yeah. So adding on sharding isn't the difficult bit. It's validating that on a shard, on any given shard, consensus is strong.
Yes.
Because that's your attack vector. I would attack a single shard. I wouldn't attack the entire network. I'd attack a shard because if it's correct on the shard, then it's correct on the network. So I want to attack there rather than the other concept of attacking the entire network. So we had to validate that bit much more than we had to do the data architecture bit, because the consensus itself was designed for the data architecture that's already there. We're not trying to shoehorn a data architecture in later.
Into something which doesn't necessarily fit it.
Exactly.
Which is where some existing blockchains may have problems.
It's where all existing blockchains have problems, yeah.
Well, I was going to actually ask you then, I think the obvious one that is popping to mind is Ethereum. Everyone knows that Ethereum is going to be attempting sharding in the future. How do you view that? Do you think, I think you've kind of answered it there already, but could you elaborate on it further? So you think that maybe their mechanism doesn't perfectly suit it, and therefore it's going to be more difficult for them to adjust in the future?
So I find it really difficult to talk about Ethereum, because Ethereum was like my first love in
I love Ethereum too.
In crypto, and I have a massive amount of respect for the guys in the Ethereum Foundation, for Vitalik and what they do, and I think that they are basically, what they're trying to do is fix a car once it's moving.
Okay.
So like they put this thing in motion, and now they're trying to upgrade it as it's in motion, which is really difficult to do. So the way that they're trying to approach sharding with things like Casper is going, okay, well, what we don't want to do is cut up the attack vector. We don't want to go, these nodes over here do these transactions, these nodes over here do these transactions, and so I only need to attack 50% of the total nodes in the network, when previously I had to, well, I only have to attack 25% of the total nodes in the network, when previously.
51% attack with half the number.
So what they've done instead is they've gone, right, we need a really solid main chain, which is going to be essentially the central chain where all the proof of stake occurs, right? And then we're going to have a bunch of side chains that are coming off it, where we're going to be writing back the states of those side chains to the main chain for validation of the main chain. So the security of each of these side chains is being enforced by the security of all of the consensus on the main chain. So you're like basically inheritance of security to the side chains. But they've gone, we're going to do 100 shards. And the shards don't do cross-shard transactions very neatly. It essentially has to be validated on the chain that the transaction is on, go back to the main chain for validation, and then be passed across to the subchain, the other chain for validation, and then validated on that chain. So you've got like 3 steps. It takes a long time. It's got a lot of overhead. The problem with that is that as you increase the number of places that it's been cut up into, you increase the probability that any transaction will be crossing shard space, right? So if you've got 100, you've got a 1 in 100 chance. But as you get to a very big data problem, like we were discussing before, and you've got 18.4 quintillion, you have a 1 in 18.4 quintillion chance of being in the same shard, which is basically nil. So all transactions start to be cross-chain transactions. And so as you can see, is that it starts off being like, oh, this scales really nicely because I'm moving things off the main chain onto the subchains.
But the actual communication between the chains becomes a nightmare with the consensus mechanism they've used.
The communication between the chains becomes more and more a certainty, which means that you're back to the main chain problem of the main chain doesn't scale more than 500 transactions per second. So you start off being like, oh, this is great, I've unloaded a load of stuff. Then you add more and more shards and suddenly, oh shit, I've got to load back up all of this stuff to cross between the shards in a consensus constrained way, in a way that doesn't break the security model. So it doesn't actually help you long term. It makes it more efficient in the short term, but the more shards you add, the more of a problem that main central chain becomes, and that's inherently the problem with blockchain scalability, is it doesn't actually work in a sharded environment properly over the long term.
Okay, that's fascinating, very fascinating. I think I never pretend to be a technical person. I'm always quite honest in the fact that my knowledge is the business side, but I think I have actually, from this and our conversation before as well, I feel like I have a much better grasp on sharding now. And it's a very fascinating kind of way of increasing the scalability of DLT. But it will be, I'll need to go away and start doing research to see how things like proof of stake can be sharded. Because as you say, if it's not the right proof mechanism for it. So if that's the case, then actually I'm just thinking, why are they switching to a proof of stake mechanism? Bearing in mind that they can see this coming in the future.
Okay, so like there's loads of sub-debates around this, right? So like proof of work is really environmentally unfriendly, it uses a lot of electricity, it's very expensive, and it's not of a great use of resources. There's plenty of people who argue with that and say, well, we already use those resources. I'm not sure, like for securing in a different way, I'm not sure that's necessarily a fair argument, because the actual argument is if you can do it more efficiently, you should. Like if you can find ways of saving electricity, or find ways of maintaining security without wasting effort, then that's a good. It doesn't matter whether or not we currently do it, therefore it's fine. It's a can we do better? The problem with proof of stake is that on Ethereum is nothing to do with sharding. Like proof of work or proof of stake, whichever one you choose, is going to have the same problems that I was talking about.
So yeah, I understand that. What I mean is, so if they see sharding coming in the future, why are they moving to a system, i.e. proof of stake, which isn't necessarily correct for sharding?
Oh, I see what you're saying. So part of that is the moving vehicle thing, right?
Okay.
You
can't switch to a consensus mechanism that is ideal.
Because like your data architecture is a big driver of what you can actually put on top of it. And I will keep going back to data architecture because it is the core of this. So if you have designed the system in some way that is immutable, and all your transaction history and validations are stored in some way that is immutable or supposed to be immutable, then you can't just go, oh, we're entirely changing the way that this functions, because that may actually break your old way of validating transactions and going back and checking if something is still valid. So you'd essentially be stopping Ethereum, saying no more transactions, and then go Ethereum new, which is a completely new system, and we're just and like if you want to refer back, you just have to refer back to the old database, and everything new is on the new one. So it's just a massive change, and there's also a load of other things that are more business related, which is people have invested they've bought Ethereum Ether on the idea of being stakers and wanting to be part of the proof of stake mechanism and stuff like that. So there's a lot of basically vested interests that sort of move behind this as well in terms of why they've bought into the system, and that all creates problems as well. So it just becomes political and difficult and immovable and complicated, and that's part of the reason, right? Yeah. So it's also a factor of carefully rolling updates that are incremental improvements. Once you've built the system, you don't want to break everything. You just want to go, we can see an incremental improvement, let's roll that incremental improvement and move on to the next thing. And that's what they're doing. And that's fine. It just doesn't get us to the end state that we need to, ultimately, for there to be a platform that the entire world can rely on, because nothing that is being implemented at the moment actually gets there. It gets us a little further down the road.
Okay, so we've been talking about Ethereum for quite a while now. Let's talk a little bit more about Radix.
Okay.
You guys have been working on this for 6 years.
Yep.
You already have your alpha launched.
Yep.
And you have an application which you can download on Google Play and I believe the App Store as well.
No, not iOS. It's not yet, but it's on the desktop. So you can download the desktop and you can download the wallet. Yeah. And that allows you to do...
has inbuilt messaging as well as testing out the testnet with some test tokens. The messaging was really cool, by the way.
You like the messaging?
Yes, I was testing that out with someone in my community the other day, and it was rapid and very, very interesting.
So that is on Ledger messaging. That is. There's no central server. That's literally the speed you're seeing that go at is the speed of transactions across the network. So it's quite cool.
That's awesome. Bearing in mind there are so many projects that are just doing messaging. Their entire scope of their projects is messaging. To see, I know it's quite a rudimentary design to begin with, but it's an alpha. That's the whole point.
It's an alpha.
It's testing out to see if it works. And
the question
I was very impressed.
There is a question as to whether or not we will include messaging in in our application for mainnet.
Okay.
People are very, very welcome to go and build messaging using the Radix network. They can, and it's relatively easy to do. We've got all the APIs and documentation for it, but for exactly the reason you say, like.
Why is that?
Some companies are dedicated just to messaging.
Okay.
Like building a messaging application is quite a difficult thing to do. And when you're building a startup, when you're building any company, focus is such a key, right? Yeah. And I'd much rather that the application that we put out was a really simple, very easy to use and secure example wallet application than a less good wallet application and a bad user experience messaging application. So messaging application can be done, but we have to choose our battles. So we are probably going to remove messaging from the scope for now, but it's absolutely possible to do, and you can play with the current alpha that has it in it.
I was testing it the other day. But even if you're taking out messaging, it's just really cool to see that could be built in, and you guys have done that. So you didn't have an ICO either. As I said earlier, you kind of saw all that happening. Could have easily raised a lot of money. You have a fantastic team, been building something for a long time, but chose to go down the more professional route and not get the cheap, easy money. So
there's a few reasons for that, and actually one of them I think is overlooked.
What's that?
One of the first companies I started was Nifty, which made a little storage device for the MacBook computers. It was just like a crazy fun little idea that I had. It wasn't there wasn't anything like I designed it in a weekend and I soldered it together and like within a week had a prototype and then put it on Kickstarter and it went crazy because people really wanted it. One of the things that I learned from that experience was, or I think I learned, I hope I learned, was taking people's money and then delivering something late or different from the specification that you set out is an incredibly stressful activity.
I've been on Telegram.
Right.
I've seen it.
And this, my product, the Nifty Mini Drive, was a $30 product. And people literally lost their cool over a $30 product being delivered a couple of months late. Like, that happens, right?
Yeah.
Especially when you're working things out for the first time.
Yeah.
And I can't imagine what it must be like for some projects who raise a load of money in ICO and then have people who have given them thousands, tens of thousands, or millions of dollars, and they aren't delivering, or they've got internal problems with the team, or whatever. And like,
I can't imagine.
Yeah,
There's a lot of it right now. Most of it.
And it's a really hard thing. So you can go, let's take the easy money. That's definitely a route, but I think that overall it's going to cause a lot of people to have a lot of problems.
Yeah.
There's also these concepts like down rounds. So if you raise too much money too early, then don't get the transaction, and then you get a lower valuation.
Previous investors don't like it.
Previous investors hate it. New investors also dislike it because they're like,
why aren't you growing?
Why aren't you growing? So instead of being like, we raised 2 million, then 5 million, then 10 million, then 20 million, then 50 million, based on key milestones of traction and delivery, you raised 50 million with an idea.
Yes.
Like, where do you go from there? Especially if it's lost like 90% of its value because the crypto crash. So people gave you 50 million, but you've only got 5 million in the bank. Your burn rate is sufficient for you need to raise the next round, and you're going to raise on more than $50 million valuation? Probably not, because you probably haven't reached that traction phase for like a Series D that would warrant. So I think that there's a lot of good reasons to take the right amount of money you need for the company at the point it is, reach the milestones, and then move to the next level, than just trying to get as much money as you possibly can.
Yes.
But when money's easy or incredibly cheap or feels easy, and this is the thing, feels easy, right? Like, you don't know what the actual heartache is. I take $1 million off someone, but I've also got an obligation with that person to quite a large amount of money that has ramifications later on.
Not a legal obligation, though. That's part of the problem. With utility tokens, a lot of these projects have raised ridiculous sums of money with, as you say, just ideas. Nothing more than that. They write a white paper you could probably write in a weekend. Now they're worth $50 million. And the worst thing is, looking from the investor's perspective, not only are they 90% down, but the SEC talked about those two projects, and they said people could claim money back in certain situations, but that's literally just America. For the rest of the world, people have invested into ICOs, been heavily screwed, and have nothing.
Right.
Can't go back. Can't claim anything.
Right.
Can't ask for a refund.
Right. And there's a lot of investor learning that's going on as well as entrepreneur learning here. So
absolutely. But either way, as I say, I respect it a lot. I think you guys did the right thing. But it now brings us to the roadmap.
Right.
Kind of, where are you guys at the moment? You have your testnet up and running, you have your application, and then the interesting question, which I asked earlier, was you had, in a previous talk, you basically explained that you had 10,000 transactions per second running on your testnet.
Yeah.
But when I looked, it was between 1,500 and 1,800.
Yeah.
And previously 10,000 had 10 nodes, now it's 20 nodes. With you guys being horizontally scalable, you should in theory have more transactions per second with more nodes.
More nodes, yeah.
So why is that changed? Why is it lower?
That's very, very, very good research of you. So it really depends on a few things. Your the resources available to the node has a big impact on the amount of transactions that it can validate. So a bigger node with more CPU, more RAM, can process more transactions than a smaller node with smaller CPU and RAM. And the level of redundancy that you put into the network. So if you run 10 nodes with 0 redundancy, and each of those are capable of doing 2,000 transactions per second, you should theoretically see a total throughput of 20,000 transactions per second. So we had 10 nodes running at 2,000 transactions per second with one-time redundancy. So dual redundancy, so 2 nodes per shard group. Now, on the current network, you have 20 nodes with a lot smaller resources running at a similar level of redundancy. And the reason we do that is because we run that 24 hours a day, 7 days a week. And there's a cost associated with actually running that in on servers, right? Because we have to pay every day for the use of those computers. So we looked at the numbers and we went, okay, what we could do is we could keep pushing really high numbers
and burn a lot of your
and burn a lot of money, but where we can't actually scale, keep scaling up because we're still in a uni-sharded environment, right? So until we break that into the 18.4 quintillion shards, it's not worthwhile us pushing the numbers too much higher, because it basically, we get to a certain point and we get to the maximum throughput of an unsharded environment, which we've done up to
around about 80,000.
We've done up to 26,000 transactions per second on that. We think we can get 80,000 transactions per second out of it. We haven't actually validated that on the testnet, but just looking at how the network operates, that looks about feasible. So we've taken the decision that until we've implemented sharding in the testnet environment, we're not going to push the numbers much above just being like, oh, look, Visa scale. And I think that's scheduled for later on this year, basically. Before we launch, we'll be pushing those numbers significantly more. But peaking them rather than
rather than wasting all your money, keeping them high and looking like it's fantastic.
So we'll be like, okay, we're gonna do this for a week, and then we'll go back to this for a bit, and then we'll do this for a week, and then we'll go back to this for a bit.
Let's talk about the network effect now. So essentially, the current roadmap indicates the technical launch is hopeful for Q4 this year, and the economic launch is going to be at least 2 months after, so probably
at least 3 months after,
At least, so at least 2020.
At least 2020,
Now, network effect is everything.
Yes.
We all know that you can have the best tech and that means absolutely nothing.
Yes.
What, are you concerned at all with other projects currently building up their network effect? Like, you could argue Ethereum hasn't scaled and you don't have successful dApps, but you do have a lot of developers. EOS every other day is actually gaining more and more legitimate users onto their platform. How are you viewing those at the moment? And are you concerned at all that they're building a network effect while you're in the testnet phase?
Yeah, so it's a really interesting question, and part of that comes down to what do you think, not you, but what does someone think is the killer application for crypto? And if people think the killer application for crypto is gaming, which is where EOS is spending a lot of its time looking, or decentralized applications like Ethereum, so Augur or Gnosis or any of those kind of platforms, then yeah, we are definitely behind on that game. The thing is that, as I was saying to you last time, I don't think those are the killer applications for public DLT. I think the killer applications for public DLT are relatively everyday. They're relatively boring and inverted. I find them interesting, but a lot of people are like, I want a decentralized autonomous organization. It's like, great, that isn't going to exist for a very long time. It's not going to exist in an effective way for a very long time, because there's so many things that we need to think through. Governance and game theory being a massive part of that. There's like 2 unsolved problems there in how you do that in a fully decentralized governance space for a decentralized autonomous organization, let alone all of the other stuff that comes into it. So I view those as experiments. I view those as windows into what will be in the future, great applications, but are not yet, like the internet. If you look at the IPO boom of the 1990s and look at all of the companies, or a lot of the companies that failed then, a lot of their ideas were good. The infrastructure wasn't there.
Yes.
The customers weren't there
Yeah.
because no one had an internet connected. People didn't really have internet connected computers and didn't really like spend online with credit cards.
Yeah.
There was all these like low level things that needed to happen before something like pets.com was a viable company. Like buying your pet's food
Makes sense.
over the
But not then.
internet doesn't sound crazy now.
No.
But like people pointed to it just after and they're like, that is the stupidest idea ever because no customers came.
Okay, so then what is your use case? What is the thing? It's presumably you're looking at a particular niche here and thinking this is where Radix could be applied.
Yeah, we think asset-backed tokens and fiat-backed tokens are your first. Like we've got this massive stock of real-world assets.
Yes.
That.
You're jumping into one of my later questions. Perfect. Let's cover it.
But it relates to our economics.
Yes.
So everything that we're building this year, you will see funnel very much towards the concept of a decentralized clearance and settlement network that allows the easy transfer of value around it and allows any company that isn't technically competent at building smart contracts and DLT applications to come along and be able to build on top of our platform something that is secure and easy to deploy.
Okay.
And so we've really focused on that. We're like, look, tokens is a great use case. Tokenization of things is an even better use case.
Absolutely.
Let's make tokenization of things important, an integral part of how the economics function. So we bootstrap that into the system, bootstrap that use case, not only because people want to come in because there's a way of making a business case for doing that for Radix, but once you're in there, that there is a continued business case for continuing to do that within the Radix ecosystem, not just for how the Radix economics functions, but how the system functions and the value that people are able to extract from it as a result of that.
Okay, I mean, that's a very, not just, I mean, I use the word niche when we're talking about asset-backed tokens. In my opinion, that's going to be potentially 95+% of the market someday.
Right.
It's where the majority of the wealth in the world is.
Right.
It's bringing, so securities is one example of that. Bringing that and tokenizing it is just a far more efficient way of transferring it.
Right.
I've been talking a lot about that on my channel actually, and I've been talking about particularly the infrastructure behind security tokens. So I think the best thing to do, let's run through an example.
Yeah.
So like, I have a VC fund, and
No, let's not go with that example. I know where you're coming from, but my favorite example of this is actually property-backed tokens. Specifically,
that's a very good use case.
specifically debt, like so mortgage, right? Okay. Because what you got is you've got two things. You've got tokenized fiat,
Yes.
and you've got tokenized debt,
Yes.
right? And what you've got is you've got this one person who's taken a loan. They've mortgaged their house, and they are paying to a single place. They don't want to pay to all of the people, clear and settle to all those people. They just want to pay their mortgage payment every month.
Yes.
Right? So £2,000 a month. They just want to pay it into a single bank account. And then what would be really great is on the back of that all the money that comes in is tokenized, and then the right to receive the monthly payment is also tokenized, right? So I could own the entire mortgage loan, which means I get the full £2,000 per month. But I could own a tenth of it, which means that I get £200 a month. But the nice thing about that is that if I'm owning it, the tokenized payment of the money goes to the person who's holding that right to receive it.
Yes.
But the moment I send it to you, suddenly it has a new address to go to.
Yes.
So you don't need to connect the banking system with the back end, with everything, with like the way that the mortgage company is operating and all that kind of stuff. It all just happens naturally as the result of two very simple things: tokenization of a right to receive a debt payment, and tokenization of fiat in a bank account that allows you to do all of these great things, really like
Where
interesting
specifically
things.
then does Radix come in? So like in the process, if you were to explain it to someone step by step, can you do the entire thing on Radix? Would you have to use an STO issuance platform and they make use of your smart contracts? What's your specific role within the step-by-step process?
Yeah, that's a really good question. So we focus on the very simple things first. So you go, okay, what do you need to be able to achieve this? The first thing you need to be able to do is create tokens, right? How do you create tokens? Well, on Ethereum or something like that, you create a smart contract. That's really complicated. Let's not go down that route. Let's just go making tokens. You have two types of tokens. You have fungibles that are single issuance, and you have fungibles that are multi-issuance.
Okay.
Right? So a single issuance token is like a limited supply token, like an ICO. There's a million of them. I create them once, and there's never any more.
Okay.
And I, as the creator, can provably never create more of them. I can create a new set of them, but I can't create more of the original type.
Yeah.
And the second is fungible multi-issuance, which is I've created 10 of them, and now I have the ability to press a button and create 10 more. Press the button, 10 more. That is a classic case of a fiat-backed token. Right? I've got a bank account, some money comes in, I create fiat representations of that, more money comes in, I create more. So we just make that bit super easy to do.
Okay.
So just make them API calls against the ledger. And instead of having to write the smart contract code as an application layer that you have execute in the distributed environment on top of the ledger, you make the ledger code itself understand the constraints that are being asked for. So you say, I want 5 million Piers tokens. I want them to be, and I want to be able to continually mint them from this address, from this signature, and I want them to be sent to this wallet. And you just send those simple parameters to the ledger, and that is then executed in the trustless environment, and the tokens are created. There is no need to write a smart contract. And then if I want to create more of them, then I just send a new signed message to the ledger being like, I need 10 million more. I get 10 million more. And so that allows you to create something as easy as a fiat-backed token in minutes.
Okay.
Right?
My first thought for this is, with utility tokens, there wasn't much of a legal framework. With security tokens, there absolutely will be.
Yes.
So the idea of sending tokens and then someone has legal ownership makes absolute sense. It's one of the key obvious use cases here. But it's the legal aspect which I'm interested in now. So are you going to work with potential platforms? Are you in talks to provide, do you know what I mean? To provide that legal framework so that if I send you tokens, my government doesn't really recognize that means anything. But by providing a legal framework around it, potentially some of these STO issuance platforms, that's a lot of their role.
So we are not trying to be an issuance platform. We're trying to be a technology provider, right?
No. But I mean the legal framework surrounding it. How do you build that in? Is that you working with other companies, or do you build that in yourself?
Got you. So it just starts very simple and you get more complicated. So you start with single issuance and multi-issuance tokens and just that. And then the next thing you go to is simple multi-sig, so that you can apply rule sets to how those tokens can move, right? So then you can go, okay, every wallet that receives these tokens has to be a multi-sig wallet, and one of the signatories has to be the company that is issuing these tokens, so that if someone wants to transfer it to someone else, the company has to be a signatory to that. And so then all of the other legal stuff that fits on top of that, you don't have to make as ledger logic. You can just go, it's logic that is triggered when someone wants to do something, and then you look at what the non-ledger logic is, which is whether or not that company will decide to sign or not sign. You don't push all of the logic down onto ledger instantaneously. You just build extra layers of it. And then the next level, you can have multi-level multi-sig and conditional transactions and all these kind of things. And these are things that we add as API calls into the ledger. But we start very simple, single issuance tokens, and single level multi-sig that allows you to do all of these things that then you can create the frameworks around. Now, we don't say this is what you have to do as a framework. We just say here's a really easy way of creating fiat-backed tokens. And the fiat-backed token example, for example, Paxos or Gemini or TrueUSD or Tether, already exists within a regulatory recognized framework on a public ledger. We're not inventing anything new. We're not trying to go to the regulator and go, would you like fiat-backed tokens? They've already said, we like fiat-backed tokens. They're fine. As long as they work in this fashion, that's cool. And we can make our system work very easily with that fashion. That's not a difficult step. You start looking at STOs, gets a bit more complicated. And the question always comes back to, how much of the logic do you actually need to push to the ledger?
Okay.
And how much of it can you just have the next level up? Because if the company is always the final signatory as to whether or not you're a private company, you get to say as a board of directors whether or not someone can sell your shares. If they can always do that, why do you need to push a shed load of logic onto the ledger? You just need multi-sig, and then the company can decide whether or not they approve that transaction. And this is the thing that starts to be interesting about STOs, is you move away from this decentralized autonomous organizations just to going, here's a way that we already do things that exists within a regulatory framework, and here's a way of making the administration of that easier. Here's a way of making the holding of the assets easier. Here's a way of making the transference of the, requesting the transference of the assets easier. Not necessarily going, let's stick every single possible rule case necessary onto Ledger instantaneously. That's not to say that...
Okay, yeah, that makes a lot of sense. So do you envision a future sort of where you are the infrastructure below companies choosing that logic?
Yes.
Okay, so you're providing them services essentially.
We are providing them tools, right?
Yes.
Yeah. So I do differentiate between tools and services. Okay. So the tool set, we say, is like, we're going to build a great toolbox for you to be able to build the things that you need to as easily as possible.
Okay.
We're not building it for you. So you don't come to us and say, hey, Radix, I would like an STO.
Okay.
We go, here's a toolbox that you can apply to the STO model. And if you want to go and build an STO, fine. But we're not saying we're building you an STO for you.
Yeah.
Right? This is just the platform on which you can, if you wish, deploy security token offerings and asset-backed tokens and all these kind of things, and we're going to try and make those tools as easy as possible for you to do so. But we're not, we can't build everything, because that's just not a scalable way of building a company that is a fundamental technology provider.
Okay.
You can't, so, and this all comes back to our mission metric method. So our mission is to give anyone, anywhere, friction-free access to the digital economy, whatever form that may take. Our method for doing that is to give developers and the world the best tools to build and deploy on top of Radix. And that's the recognition of, we may be wrong that fiat-backed tokens is the killer application for Radix. We may be wrong that security tokens is the killer application for Radix.
I don't think you are.
But if we make a great set of tools, then it doesn't matter, because people can come and apply it to whatever they want to, right?
Yeah.
People built computers for work, but they've also become great gaming stations, right? Yes. People built web servers for one thing and they've become something else. So like all of these things is just like, how do you create a technology that people can innovate on top of?
Okay, that's fascinating. So what do you view then at the moment? We've got Ethereum ERC20 and some protocols, some like issuance platforms. I know you're not an issuance platform, but they are essentially using Ethereum as a tool to build on top of, and they're using Ethereum smart contract. You know what I mean? They're using the smart contract capabilities, and they're building their services on top of that. Some people are building, like, I think Harbor has the R protocol, Securitize has DS or something like that. There's all of these different protocols. Why would someone come to Radix and use your tools over, I assume with Ethereum it's scalability. What about these other protocols?
Scalability and ease of building, really. Like, it's the complexity of deployment. Always ends up being a big issue. Oh, and now I get to talk about the economics, right? Because the economics is coming out today, so I can actually talk about it. So the other big thing that is a problem for companies on decentralized systems is, this is a piece of infrastructure on which I want to rely on for my company, right? So there's two questions to that, actually not one, but we always forget the second one. The first is it fit for purpose? And like underneath that can be security, scalability, usability, and all these other stuff, but is it fit for purpose? The second is it cost effective, right? And the problem with Ethereum, Bitcoin, EOS, any company that has a fixed supply token or a commodity-like instrument as their token is, I, as a business, can't predict what the cost of using that system is going to be.
Yes, it's Too volatile.
Too volatile. So it could cost me $2,000 a month, could cost me $20,000 a month. 1 month, I absolutely have to use it to hit my SLAs, my service level agreements with my customers, but there's nothing in the market, so I have to buy at a ridiculous cost. That's a real problem for a company going, oh, I'm going to base a key piece of infrastructure. Like when companies decide to use software, they'll often sign 5-10 year service agreements with fixed cost because they need to know what it's going to cost them to use that system, and you just can't get that with the current DLTs.
So what about then permissioned blockchains? Some people believe this could be a potential use case where regulation comes in and we don't necessarily need not immutability, but I'm trying to think of decentralized access, like anyone joining a network, permissionless blockchains. Permission blockchains. What do you think of them in this case then?
So it's one of those. Ow.
That's it.
What's the? Okay.
And that is where we had to finish. Unfortunately, Piers had to run to a meeting. There were loads more questions which are running through my mind, but we did cover pretty extensively what Radix are trying to achieve. I'd like to say a big thank you to Piers because I really enjoyed the interview. It was fascinating learning about the project. And as I was kind of indicating throughout the interview, I learned a lot about sharding, particularly from that time.